In this episode, we are taking a close look at one of the least glamorous parts in a computer and one of the most important, because the power supply is the component that decides whether the rest of the machine gets stable, usable electricity, or a constant stream of problems. Brand new learners often focus on processors, memory, storage, and graphics because those are the parts users talk about most, but experienced technicians know that a weak or poor quality power supply can make good hardware look broken, unstable, or unreliable. Many support problems that seem mysterious at first, such as random shutdowns, failed startups, disappearing devices, or strange crashes under load, can often be traced back to bad power choices rather than bad software or defective components. Once you understand what a power supply unit, PSU, actually does, how technicians plan wattage, why connectors matter, and what installation details affect long-term reliability, you begin to see that selecting a good power supply is not a minor shopping choice, but a core system decision that shapes the health of the entire build. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. At the simplest level, a PSU takes electricity from the wall and converts it into the lower, controlled forms of power that computer components can safely use. That sounds straightforward, but the important word is controlled, because the system does not just need electricity, it needs power that is steady enough for delicate electronics to trust moment by moment. The motherboard, processor, storage devices, cooling fans, and graphics hardware all depend on the PSU to deliver power consistently. And when that delivery becomes weak, noisy, or unstable, the symptoms often spread across the entire system in ways that confuse beginners. This is why technicians do not treat the power supply as a simple box with cables, because in practical support work it acts more like the machine's power foundation, and a shaky foundation can make every other component behave as though it has a problem of its own. A computer can only be as dependable as the electrical support feeding it, which is why technicians learn early that stable power is not a luxury feature, but a requirement for a trustworthy build. One of the first ideas beginners hear about power supplies is wattage, and it is easy to misunderstand what that number really means. Wattage is not a promise that the computer will perform better on its own, and it is not a signal that the biggest number is always the smartest choice. Instead, wattage planning is about making sure the PSU can comfortably support the total power needs of the system, including the processor, graphics hardware, storage devices, cooling fans, and any future upgrades the user may add later. A supply with too little capacity may still allow the machine to power on at first, but it can struggle when the system begins real work, especially during gaming, heavy processing, large file transfers, or other moments when several parts need more power at the same time. Good technicians choose enough wattage for the system to run cleanly with some room to spare, because a build that operates too close to its limit is far more likely to show unstable behavior, sudden shutdowns, or reduced reliability over time. That extra room matters because modern systems do not always draw the same amount of power every second they are running. A computer sitting quietly at the desktop may appear calm and efficient, but the moment a graphics-heavy task starts, or the processor begins sustained work, the demand can rise quickly. Technicians think about these changes in load because APSU should handle not only normal operation, but also those moments when the system briefly asks for more power than its idle state would suggest. Choosing a unit that only barely matches the expected demand can create a computer that looks fine during basic testing yet fails when a user begins doing the exact tasks the machine was built to support. At the same time, technicians do not choose wildly oversized units without reason, because the goal is not to chase the largest possible number, but to select a reliable, appropriate supply that fits the system, supports realistic future growth, and operates in a healthy range rather than near exhaustion. Another idea that often shows up in discussions of power supplies is efficiency, which is usually described through rating systems that tell you how well the unit converts incoming electricity into usable power for the computer. A more efficient supply wastes less energy as heat, and that can matter for electricity use, internal temperature, and overall operating quality. Beginners sometimes make the mistake of thinking that an efficiency badge alone proves the unit is excellent, but technicians know that efficiency is helpful information rather than a complete quality judgment. A supply can be reasonably efficient and still be a poor choice if it is badly built, unreliable, or mismatched to the system's needs, while a well-designed unit earns trust through stable output, solid construction, and dependable operation under real conditions. In support work, efficiency is part of the evaluation, but it sits alongside build quality, brand reputation, connector support, cooling behavior, and realistic wattage planning, because the best choice is the one that performs well as a whole and not just on a single label. Connectors are another area where a power supply can look acceptable until the technician checks what the system actually needs. The motherboard usually requires a main power connector and a separate connector for the processor, while graphics cards may need their own dedicated power leads, and storage devices and other internal components require their own cable types as well. A PSU that seems powerful enough on paper can still become a bad choice if it lacks the right connectors, if it forces the use of awkward adapters, or if its cable layout makes clean installation difficult inside the case. Technicians avoid guessing here because the wrong connector situation can create more than inconvenience and can lead to poorly routed cables, strained connections, blocked airflow, or hardware that never receives the kind of stable power it was designed to use. This is especially important in modern builds with stronger graphics hardware or multiple devices, where connector count and connector type are just as important as raw wattage when deciding whether a unit is truly compatible. The physical size and shape of the PSU also matter more than beginners often expect. A power supply must fit the case correctly, align with the mounting points, and leave enough room for the rest of the system to breathe and for cables to be routed cleanly. Some desktop cases are designed for more traditional full-size supplies, while smaller systems may require more compact units, and a technician checks that fit before recommending or installing anything. A supply that is technically powerful enough but physically awkward for the case can make installation harder, reduce airflow, crowd other components, and turn simple future maintenance into a frustrating experience. This is one reason experienced technicians always think of the case and the power supply together, because even a quality unit becomes a poor support decision if it forces the machine into a cramped layout with poor cooling and messy cabling that makes every later repair more difficult than it should be. Modern builds also push technicians to think about the PSU as part of the system's long-term plan rather than just today's power requirement. A computer built for office work may need modest, steady power, while a system designed for creative applications, gaming, lab work, or multiple storage devices may need more headroom and a stronger overall electrical foundation. Technicians ask what the machine is supposed to do, what upgrades are likely in the near future, and whether the current power choice leaves room for those changes without forcing another replacement too soon. That planning mindset helps avoid the common beginner mistake of buying the cheapest acceptable supply for the current parts, and then discovering later that a new graphics card, more drives, or additional cooling equipment pushes the system beyond what the original choice can handle safely. Good support work is not just about making a machine start today, but about making sure it can continue working reliably as the user's needs grow and the hardware evolves. Installation itself is another place where power supply decisions show their quality, because even a good unit can create problems if it is installed carelessly. A technician makes sure the supply is mounted securely, that its fan orientation makes sense for the case design, and that cables are routed in a way that avoids sharp strain, blocked airflow, and unnecessary pressure against other components. Clean cable routing is not just about appearance, because crowded or tangled cables can interfere with cooling, make fault tracing harder, and increase the chance that a connector works loose during transport or later maintenance. Technicians also verify that every required connection is fully seated, since a partially connected motherboard or processor cable can produce behavior that looks like major hardware failure even when the real issue is simply incomplete power delivery. In other words, installation is not the final easy step after selection, but part of the larger reliability picture, and careful power supply work continues all the way through the last cable check. When a PSU is wrong for the build, one of the first symptoms that often appears is sudden shutdown behavior. The machine may run for a while and then turn off during gaming, heavy processing, or any task that causes the processor and graphics hardware to pull more power than they need at idle. Beginners sometimes blame overheating first, and that is understandable because heat can cause shutdowns too. But technicians learn to notice the timing and pattern of failure because a system that dies mainly under electrical load may be revealing a power weakness rather than just a cooling issue. A supply that is underpowered, aging badly, or poorly built may lose stability when demand rises, and the user experiences that as a random power loss even though the machine is actually telling a more specific story. This is why technicians connect sudden shutdowns to power planning so often, because the problem is not always that the system cannot turn on, but that it cannot stay healthy once real work begins. Boot failures are another classic sign of power trouble, and they can appear in several misleading ways. A machine may do nothing at all when the power button is pressed, may briefly spin fans and then stop, may turn on without completing startup, or may seem to behave differently from one attempt to the next. Those patterns can lead beginners to suspect a dead motherboard or failed processor immediately, but technicians know that poor power delivery can prevent the system from ever reaching a normal startup state. If the board does not receive stable power, if the processor connector is missing or loose, or if the supply cannot support the initial startup demand consistently, the machine may never get far enough to tell the user what is wrong in a clear way. That is why support professionals check power connections, supply quality, and overall PSU suitability before replacing expensive components. Because many so-called dead systems are actually underpowered, improperly connected, or suffering from a failing supply rather than from a bad motherboard. Unreliable hardware behavior is where power problems become especially deceptive because the symptoms can spread across devices that look unrelated. A system with poor or unstable power may show storage errors, device disconnects, graphical glitches, failed wake behavior, strange restarts, or intermittent problems with universal serial bus, USB, accessories, and none of those symptoms automatically points a beginner toward the PSU. Yet technicians know that weak power can make healthy components misbehave because every device in the system depends on the same electrical foundation. That is why power issues are so often blamed on software, drivers, or individual parts at first, since the user sees the symptom at the device level while the deeper cause sits lower in the platform. A calm troubleshooting mindset helps here, because once a technician notices that several different parts are behaving inconsistently without a single clean pattern of failure, the PSU becomes a much more likely suspect than any one device being blamed by the user. There are also several common mistakes that technicians learn to avoid when choosing power supplies for modern systems. One is selecting by wattage alone and assuming that a bigger number always means a better unit, when in reality build quality, connector support, electrical stability, and reliability matter just as much. Another is reusing an old supply from a much older system without thinking about connector needs, age-related wear, or the fact that a unit that once worked well may now be far less dependable after years of heat and use. Technicians are also careful with modular cable systems, because cables from one power supply are not something to mix carelessly with another, even if they look similar at a glance. These habits matter because the biggest support headaches often begin with shortcuts that seemed harmless, and careful technicians understand that the PSU is not a good place to gamble, improvise, or assume that close enough will be safe enough. A good technician eventually develops a simple but powerful way of thinking about the power supply. Instead of asking only whether the computer will turn on, they ask whether the PSU fits the case, supports the connectors, provides enough real wattage, leaves room for growth, operates efficiently, and has a reputation for staying stable under load over time. That broader view keeps them from blaming the wrong part when symptoms appear and helps them choose replacements that solve problems instead of hiding them temporarily. It also explains why reliable systems often feel boring in the best possible way, because when the power foundation is sound, the rest of the machine is free to behave predictably and support issues become easier to isolate when they do happen. Power supply work may not be the most visible part of a build, but it is one of the clearest examples of how good support depends on quiet, careful decisions that users may never notice unless those decisions are made badly. By the end of this topic, the power supply should feel less like a background part and more like one of the main reasons a computer is either stable or troublesome. Wattage planning helps the system handle real demand. Connectors determine whether the hardware can be powered correctly. Physical fit affects installation and airflow, and overall unit quality shapes whether the machine will behave reliably under the stress of modern use. Wrong power choices often reveal themselves through shutdowns, boot failures, and strange hardware behavior that seem disconnected until someone recognizes the common electrical cause behind them. When technicians choose and install PSU units wisely, they are not just giving the computer electricity, they are giving every other component the consistent support it needs to do its job properly, which is why smart power decisions are some of the most important decisions in any modern PC build.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.